Hi everyone, this is Dr. Saide Falafini from Cal Poly Pomona. And in this video today, we are going to learn a new concept related to stochastic processes called mean first passage time. Mean first passage time from state I to state J, which is shown by Mij, shows average number of steps that are needed for us to get to the state J for the first time, assuming that we have started from state I. So let's assume you are right now at the state I. What is the average number of transitions that you have to take before you end up at state J for the first time? That is what we call as mean first passage time from state I to state J. Now let's see how Mij is calculated. So right now we are at state I, that's what we said. And we want to go to state J. That's where we want to end up with. So one possible scenario is that we go from state I to state J in one transition directly, and that is going to happen with probability of Pij. Another possible scenario is that we go from state I to state 1 with probability of Pi1. That would be one transition. And then we go from state 1, and then from state 1, we take whatever number of steps that are needed for us to end up at the state J for the first time. And I'm going to show that with M1J. So M1J shows average number of steps that are needed for me to end up at the state J, given that right now I'm at the state 1. Another possible scenario is that I go to state 2 first with probability of Pi2. That's going to be one step, one transition. And then from state 2, I take whatever number of steps or transitions that are needed for me to end up at the state J, given that right now I'm at the state 2. So that would be 1 plus M2J. That would be number of steps that I will take if I go through this scenario. So, or another scenario is that I go from state I to state S with probability of Pis. That's one transition. And then I take whatever number of steps that are needed for me to end up at the state J, given that right now I'm at the state S. And that would be MSJ. Obviously, we can look at different scenarios for all possible intermediate states, going first to state 1, or state 2, or state 3, 4, 5, all the way to state S. So if I want to calculate Mij, which is average number of steps that I have to take to end up at the state J, given that right now I'm at state I, if I want to calculate that, then I have to multiply all these possible values in terms of number of steps by their corresponding probabilities and add them together. So that would be either one step, this scenario, with probability of Pij, or these other scenarios where the number of steps would be 1 plus Mkj. Considering that I'll go from state I to state K first, and for all possible values of K from 1 to S. So if I can calculate this expression, that would give me Mij. And one thing I want you to pay attention to is that in this sigma that we put together, K, the intermediate state, is not going to be equal to J, because J is the final state that we want to end up with, right? So either I go from state I to state J in one transition, that's the part that I wrote here, or I go from state I to some intermediate states in one transition, and then from those states I end up at the state J. And so these intermediate states are never going to be state J. So that's why here this K, which basically accounts for those intermediate states, is not going to be J. So K is not equal to J. So now let's see how we can simplify this expression. So I can write Mij equals to Pij, and then if I multiply Pik by this number 1 in this parenthesis and then write it as two different sigmas, I will have plus sigma pik, k from 1 to s and k is not j, plus sigma pik m kj, k from 1 to s and k is not j. This is the sum of all transition probabilities starting from state I and going to other possible states but not state j, and then this is the probability of starting from state I and going to state j. So if I just add all of this together, so that would be mij equals to sigma pik k from 1 to s plus sigma pik m kj, k from 1 to s and k is not j. We know the sum of these probabilities, so this is basically the sum of all the probabilities in the transition probability matrix that are in row I. So these are the probabilities of going from state I to any other state k when k goes from state 1 to state s. So this expression basically is the sum of all the probabilities on row I of the transition probability matrix. And as we know, this value equals to 1, right? So then I can say that mij equals to 1 plus sigma pik m kj, k equals to 1 to s and k is not equals to j. So this is the final formula we have for calculating mij, the average number of steps we have to take to go to state j for the first time, assuming that right now we are at the state I. This formula helps us to calculate mean first passage time from state I to state j. But what if we want to calculate MII? What does that mean? So this is the average number of transitions we have to take for us to end up at the state I for the first time, assuming that right now we are at the state I. So right now I'm at state I and then I'm going to make a bunch of transitions. So what is the average number of transitions before I again end up at the state I? That's going to be shown by MII. And the formula for MII is 1 over pi I. So if we calculate this expression, it's going to tell us that if we are right now at the state I, on average, how many transitions we have to take before we end up at the state I again. So just keep these two formulas in mind because we are going to use them to calculate mean first passage time for between different possible states in a Markov chain. So now let's look at one example. It's going to help us to get a better sense as how mean first passage time from state I to state j is calculated. So let's go back to the cola example again. If you remember, for that example, we calculated the steady state probabilities, and those values for cola 1 was 2 over 3, and for cola 2 was 1 over 3. Now we want to calculate M11, M12, M22, M21. Since we have only two states, state 1 and state 2, these four values are the only possible mean first passage times that we can calculate for this stochastic system. So let's see what is M11. Remember, that's 1 over pi 1. So that's 1 over 2 over 3. And that's going to be 3 over 2 or 1.5. That means if I'm at the state 1 right now, on average, I have to take 1.5 transitions before I end up at the state 1 again. And the reason that you see 1.5 for the number of transitions is that it's average. So to get a sense as how this 1.5 is calculated, so if right now I'm at the state 1 and then I want to see average number of transitions that I have to make before I end up at state 1 again. So what are the possible scenarios? I can go from state 1 to state 1 right away in one self transition. That would be one step with probability of P11. I can go from state 1 to state 2. That's one transition, and then go back from state 2 to state 1. So that's two transition where I go from state 1 to state 2 and from state 2 to state 1. Or it may take three transitions. For example, I go from state 1 to state 2, and then I will do a self transition at state 2. So I stay in state 2 one transitions, and then I go from state 2 to state 1. So this is the probability that I start from state 1 and I end up again at the state 1 after three transitions. So if we write the list of all possible transitions, all possible number of transitions that can help us to end up at the state 1, given that right now we are at the state 1, if I write down all possible values for number of transitions and list their probabilities, and then at the end take an average of all of these to calculate M11, average number of steps that can take me to state 1, assuming that right now I am at state 1, this is the formula for the final value. So instead of us going through all these calculations, we are going to just use the formula. But I wanted to write all these calculations so that you know how this formula has been calculated, basically. So now let's assume I want to calculate M22. That's 1 over pi 2. That's going to be 1. That's 1 over 3. So that's equals to 3. That means if you are right now at the state 2, on average you have to take 3 transitions before you end up at state 2 again. Now let's see how I'm going to calculate M12. That means average number of steps that I have to take to end up at state 2 for the first time, given that right now I'm at state 1. Based on the formula that we had, I can write M12 as 1 plus sigma P1K MK2, where K goes from 1 to S and K is not equal to J. Since we have two states, 1 and 2 here in this problem, so S here goes to 2, so this would be K from 1 to 2, and K is not equal to J, where our J is 2. So K is not equal to 2. So the only thing that stays is that 1 plus P11 M12. And if you remember, that one step transition probability for cola example was 0.9, 0.1, 0.2, and 0.8. So this was for cola 1, cola 2, cola 1, cola 2. So if I put the value of the P11 from the one step transition probability matrix, here I would have M12 equals to 1 plus 0.9 M12. So I have only one unknown, that's M12, and only one equation, so I can just solve these equations and find the value of the unknown. So this is going to be 0.1 M12 equals to 1. As a result, M12 equals to 10. That means on average, we need 10 transitions for us to end up at the state 2 for the first time, given that right now we are at the state 1. So another way that I usually use to somehow write down this formula without going through all the sigma and everything is that I say, okay, if I want to go from state 1 to state 2 for the first time, what are the possible scenarios? I either go from state 1 to state 2 right away, that's one step, or I go from state 1 to state 1 first with probability of P11, and then I will take whatever number of transitions that are needed for me to end up at a state 2 for the first time, assuming that right now I am at a state 1, because remember the first step is from state 1 to state 1, so I'm still at the state 1. So how many transitions are needed for me to end up at a state 2 for the first time, given that right now I'm at state 1? So that logic also can help you to make sure whatever the formula you put down for the mean first passage time is correct. So now let's calculate M21, mean first passage time from state 2 to a state 1, meaning that if we are right now at the state 2, on average how many transitions we have to make before we end up at the state 1 for the first time. So if I want to write it down based on the logic that we said here, I would say, so if I start at state 2, I either go to state 1 directly in one transition, or I go from state 2 to state 2 in a self transition, and then from state 2 I will go through whatever number of transitions that are needed for me to end up at the state 1 for the first time. So you could go through something similar to this sigma, write it down and just get to the corresponding formulation that way, or just follow the second logic that I mentioned, that how potentially you can write down these formulations with just using the logic. That may be a little faster. So now if I want to calculate this, that's going to be 1 plus P22 is 0.8, M21, that's one equation and one unknown. So 0.2 M21 equals to 1. As a result, M21 equals to 5. That means if right now I'm at state 2, on average, it will take me 5 transitions before I end up at the state 1 for the first time. So that's the definition of mean first passage time from state 2 to state 1.